Hi friends, today I am going to talk important title pharmaceutical aerosols. We will start with introduction. Pharmaceutical aerosols are pressurized dosage forms that upon activation emit a fine dispersion of liquid and solid material containing one or more active ingredients in a gaseous medium. It produces local and systemic actions. Local actions such as it produced in nasal and throat area, and when the drugs absorbed from the lungs into the bloodstream and give the pharmacological action. Aerosols are advantages than some other preparations. The dose can be removed without contamination of materials. Metered valve can release the contents in controlled and uniformly manner. Stability is enhanced. The medicament can be delivered directly to the affected area. The dispersion of medicament is very good. Easy and convenience of applications. Application of medicaments in thin layer. Here we discuss about the various components of aerosol system. They are propellants, containers, actuators and valves, product concentrates. This diagram shows the various parts of aerosol system. Propellants, it is the most important components in aerosol system. It is also called as the heart of the aerosols. It is responsible for development of pressure within the container by the propellant causes the opening of valve which expel the product by atomization or foam formations. It acts as a solvent for certain active ingredients. It also provides the necessary force to expel the contents. Types of propellants, there are two types, liquefied gas propellants and compressed gas propellants. First we see about liquefied propellants. The gases that exit as liquid under pressure, the headspace is filled with the gas. Two types of liquefied gas propellants, hydrocarbons and halocarbons. Hydrocarbons is used for water-based aerosols and topical aerosols. Halocarbons is a choice for oral aerosols and inhalation aerosols. Compressed gas propellants. Compressed gas occupy the headspace above the liquid in the container. The working principle behind that is when the aerosol valve is opened, the gas pushes in the liquid out of the container. So higher gas pressure is required in this aerosol. The gases are nitrogen, nitrogen dioxide and carbon dioxide. These propellants are dispensing the particles in the form of mist and foams. The ideal qualities of propellants, they are chemically inert, lack of toxicity, lack of flammability, lack of explosiveness, and it should be non-reactivity with some other components. Pharmaceutical containers, actually we are familiar about pharmaceutical containers. It is made up of glass, metal and plastics, and the pharmaceutical container should be withstand high pressure. The pressure ranges from 140 to 180 pounds per square inch gas at 130 degree Fahrenheit. This table shows that various types of container and the maximum tolerable pressure with the temperature. Valves are capable of delivering the content in the desired form such as spray, foam and solid stream. Types of valves used in aerosol container are continuous spray valve and metering valve. Continuous spray valve is used for topical aerosols and metering valve is used for nebulizers, and these are the various types of valves used in aerosol.
Now let us discuss about actuators. Actuators are specially designed buttons that aids to deliver the drug in desired form, that is spray, wet and solid stream form. The various types of actuators are spray actuators, foam actuator, solid stream actuators and special actuator. Spray actuator is used for topical preparations. Foam actuator that contains large orifice. Solid stream actuator is required for dispensing semi-solid products such as ointments. Special actuator, it delivers the medicament to the particular site of action.
Let's see components of actuators and valves. Valve, already we discussed earlier. It is to control how much of the product comes out, how fast and in what direction. Actuators, already we discussed earlier. It is a spray button which are designed to be easy to use and to control the application of the product. valve cover. It is a metal cup at the top of the container. It holds all the valve components together. Stem, it connects the actuator and the spring. Stem gasket, the gasket seals the opening around the valve stem, keeping the can airtight. Spring, which maintains pressure in the gasket, which seals the container. Housing, it is a cylinder which holds the spring and concentrate the dip tube to the valve assembly. Dip tube, it is a hollow tube allowing the product under pressure. Product concentrate, it is an active ingredient or mixture of active ingredients and other necessary agents such as solvents, antioxidants and surfactants. The drug product formulations might be in solution, emulsion and suspensions. We should have solution aerosols, emulsion aerosols and suspension aerosols. We see about the formulation of aerosols. It contains two essential components. One is product concentrate and propellants. Product concentrate and propellant both are discussed earlier. Product concentrate, it is nothing but active ingredients. It contains one ingredients or more than one active ingredients and other solvents, antioxidants and surfactants. Propellants, propellant is used in single or blend of various propellants. Blend of various propellants is used in pharmaceutical formulation to achieve desired vapor pressure, solubility and particle size. Some other parameters also we are considering while formulating in pharmaceutical aerosols. The physical and chemical pharmaceutical properties of active ingredients and the site of application. Now we will see types of system. The various types of system used in the formulation of pharmaceutical aerosols are solution system, water-based system, suspension or dispersion system, foam systems, and intranasal aerosol system. These systems are grouped on their active ingredient used and the application perspectives. Manufacture of aerosols. First we will see the overview of manufacture of aerosols. Then we first we select the empty container. To this add product concentrates, that means active ingredient. Then fix the valve, then add propellant and fix the activator, then it is subjected for quality control test. Methods used for manufacturing of aerosols: cold filling process, pressure filling process and the compressed gas filling process. In cold filling process, the product concentrate and propellants are cooled to temperature below 0 degree Celsius, that means minus 30 degree to 40 degree Celsius. However, in pressure filling method, the liquefied gas is added to the container under pressure through the valve. In compressed gas filling method, it is similar to pressure filling method. Here, compressed gas is used instead of chlorofluorocarbon. Today we discussed about pharmaceutical aerosols, manufacturing process, components and formulation of aerosols. Thank you.